So probability basically means the extent to which an event is likely to occur. So it is the branch of mathematics which helps us to find the chance or the possibility that an event will occur. So, but why do we need to learn about probability? So that is, in our day-to-day life, we come across
Yes.
uncertain events that affects us directly or indirectly. Okay, suppose
Yes, sir.
we planned a picnic. Okay, and it starts to rain
Yes, sir.
heavily. So in this case, the event of heavy rains has ruined our plans for the day. Okay, so if we could predict the possibility of heavy rains, we would have chosen some other day. So probability helps us to make favorable decisions when we are not sure of the outcome. Okay, let us see some examples where probability is used. Yeah. So even probability is also used to predict the chance of winning different events like a lottery ticket, right? A coin
Yes.
tossed or a dice is rolled. Okay.
Yes,
So
sir.
let us find out the probability of an event. So considering the scenario wherein I have a bag, right, which is uh, which is consisting of okay, a bag which consists of uh, one five red, okay, and five green, okay, balls, okay, okay.
Yes, sir.
Now suppose we open the bag and randomly pick a ball without looking then. So what is the probability of picking a green ball? Okay, let us understand uh, how to calculate the probability. Okay,
Yes, sir.
so let us see how is it done. So what is the probability of picking a green ball? Let us first assume that the event of picking a green ball is G. Okay, if you
Yes,
consider
sir.
G, okay, then the probability of picking a green ball will be P of G, okay, which is equal to the favorable outcome by the total outcome. Outcomes. Okay. So how
Yes,
many
sir.
green balls do we have in the bag?
5.
Five. Five green balls. Then what should we write uh, in the place of favorable outcome? Favorable outcome. What should we write? Five. Right?
Yes, sir.
Yeah. So what is the total number of outcome? Total.
5.
Total
Total 10.
10. Right?
Yes, sir.
So 5 divided by 10. So that is the probability of getting green, right?
Yes, sir.
Right. Which is nothing but 0.5. Okay. The basic terms related to probability, that is, a random experiment is a process by which we observe certain uncertain An outcome is the result of a random experiment. An event is collection of basic outcomes with specific properties, and sample space of a random experiment is the set of all possible outcomes. Okay, so probability is equal to the number of favorable outcomes by the total number of outcomes. Okay,
Yes, sir.
yeah. And probability of an event calculated by conducting experiments is called empirical probability. So empirical probability, that is P of E, okay, of an event E happening, okay, is given by, that is P of E is equal to number of trials, number of trial in which the event happened or occurred by the total number of trials, okay, trials. And the two important properties, that is please remember, that is first one, property, that is the probability of any event lies between 0 and 1. Okay, so
Yes,
if
sir.
I draw a line 0 and 1, so P of A is less than or equal to. And another property, that is the sum of probabilities of all the events, okay, in a given sample space is 1. Okay, so please remember this. Okay, let us solve this.
Yes, sir.
Okay, so it is given that in the last 10 matches, India won the toss 6 times.
Yes.
Okay, so this means out of 10 matches, matches in which India won the toss is 6. Okay, matches in which Australia won the toss is 4. Australia. And we have to find which team is more likely to win the toss. So since we know the frequency of winning the toss, we will have to find the empirical probability of each team winning the toss and then compare them with each other to find which team has the higher probability of winning the toss. So let us start with Team India. Okay, so let us assume the event of India winning a toss as E event. Okay, so the empirical probability of India winning. Okay, let us name that as I, since India, right? So let us put that as I. Okay, so that will be P of I. Okay, empirical probability of India winning the toss is given by P of I. Then that would be P of I will be number of tosses India won by total number of tosses. Okay, so what is the number of tosses India won?
6.
6, right? And what is the total number of tosses?
10.
10. So let us substitute that. So P of I will be 6 by 10, which results to 0.6. So probability of India winning the toss is 0.6, right? So let us assume the event of Australia winning a toss. Okay, so that is A. So the empirical probability of Australia winning the toss is given by P of A. Okay, so that would be P of A, which is equal to number of
Tosses Australia
tosses
1.
Australia won
1.
by total number of tosses, right?
Yes, sir.
So the number of tosses England won, which is 4, and the total number of tosses, which is 10. So which will be
0.4.
0.4. Yeah, we can say that India is more likely to win the tosses. Okay, so probability of I is greater than probability of A, right? So, so that solves it, solves the problem. So let us solve this. The possible outcomes of head and tail. Okay, so
Yes, sir.
number of exhaustive cases, which is 2, which we represent as n, which is 2, and number of favorable, okay, which we represent as m, which is 1. So probability of getting head, which is m by n, which is 1 by 2. So let us solve this. So here we have been given the frequency of head and tails when a coin is tossed 1,000 times.
Yes, sir.
And we have to find the probability of getting head and getting tail. The first step is we name the required event. So let us assume the event of getting head is H. So the empirical probability formula of getting head would be P of H. Okay, P of H, which is equal to number of trials
Right.
in which head occurred or happened by the total number of trials. Okay,
Yes, sir.
so what is the frequency of head and the total number of trials?
455 divided by 1000.
Yeah, 455 divided by 1000. So you get this as
4
0.455. Okay.
Yes, sir.
Now let us find the probability of getting tails. So let us assume the event of getting tails is T. So P of T, empirical probability, P of T is given by the number of trials in which the tail happened divided by the total number of trials. So tell me the frequency of trials and
Five
tails and the total number of trials. It is
545 divided by
545
1000.
by 1000. Okay, so which we get that as
545.
0.545. Okay, so therefore the probability of getting tails is 0.54. Okay,
Yes, sir.
so now let us understand the classification of event based on the probability scale. Okay, the probability of an event lies between 0 and 1, including 0 and 1. Okay, we know that the probability of an event always lies between 0 and 1. Okay,
Yes, sir.
in this range we have three possible values for an event, that is 0 equal to 0, between 0 and 1, and equal to 1. So let us represent these three values with the help of three different events, that is A, B, and C. Okay,
Yes, sir.
okay. So now A is the event whose probability of occurring is equal to 0. P of A, which is equal to 0. P of A is equal to 0 is A is an impossible event. Next is the event B has a probability between 0 and 1. Between 0 and 1. Okay, so which where B is a probable or possible event. So P of C, which is equal to 1. C is called the certain event. Okay,
Yes, sir.
Yeah.
Yes, sir.
Okay. So let us solve this. So number of possible exhaustive event, which is n, which is 52. A card, a pack contains 52 cards, right? N is 52. So let us consider the first one, getting king. So number of favorable, which we represent as m, which is 4. And therefore the probability of getting a king, p, which is m by n, which is 4 by 52, which is 1 by 30. The second one, number of favorable cases, king or queen, which is 4 plus 4, which is 8, which is number of favorable cases. So therefore, the probability of getting a king or queen, which is by n, which is 8 by 52, which is 2 by 13. Okay,
Yes, sir.
so let us solve that. Okay. So the box contains 3 white, 5 black, and 6. So 3 plus 5 plus 6, which will be 14. That is the total number of balls in the box. Okay. Now, the probability of getting a red. Okay. So, which would be 6 by 14. 6 by 14. And probability of getting white, which will be 3 by 14. Now, or, right? Or will be probability of getting red or white. So, which will be 6 by 14 plus 3 by 14. So, which results to as 9 by 14. Okay, by addition theorem, since two events are exclusive. So, the required probability is 9 by 14.